Alrighty, guys, let's get our second project going. The Tappy Plate project is, in my opinion, a little bit simpler than the Brick Breaker project, but it does get us into a few more advanced what's it called? Advanced topics. So I'm gonna pull up my notes on the side here. We're going to get our repeating backgrounds started. Um, if you are following in my 110 class, we likely have like done this in class already once. So this should just be a catch-up thing. And the very first thing that we do in any project, I'm not going through how to make a project again. This should be pretty self-explanatory, but the setup is the same, right? So I'm going to make a art folder. I'm going to make a scripts folder. Scripts folder, and I think we're just going to chill with that. So I have already downloaded the Tappy Plane assets, so I'm going to go ahead and extract those. I'm doing that on my other screen here, and here we go. There's my art assets. They look great. They're wonderful. I'm going to drag them into my art folder so that I have them in there. Now, my background is 800 by 400. I'm going to go ahead and drag that in right out the gate. And we've already talked once, if I go and move this, or I think it was 800 by 480, my bad. Main camera is at 000. I'm putting my background in at 000. And first things first, I want to get my camera working like, so that way it takes up the whole screen, right? And we said that the size is from the middle of the screen up. We know our size is 5. Our height here is 480, so half of that would be 2.4. Perfect. And yeah, we have a little bit of blue on the edges, but that's okay, because we really do want to have 2 of these, right? Because ideally what's going to happen is we're going to have it scrolling side by side. And you might think in an infinite runner game, because that is what Tappy Plane is the we would keep spawning in more backgrounds and going, and or we'd lay out a whole bunch and go very far to the right with our plane here. But that's not the case, right? That's not how we want to go about doing that. We want to have the plane, and let's go ahead and drag that in too, just so that we have them in. Oh, we have that one issue again. This time around, I'm not going to go and do all my sorting layers. I'm not going to add extras because I know that the game isn't going to be too complex. I'm just going to leave my plane on 1 and my backgrounds on 0. So what's going to actually happen is the plane is never really going to move horizontally. We're just going to keep spawning things in and moving the background one after another, and have it just kind of cycle. Because if we were to zoom out really far and just have our plane keep going, you notice right now I have the plane at 4,000. If that keeps going, eventually you're going to run into big number problems where it's just like you're calculating these giant numbers and there's really no reason to. So let's get our background moving just to start, right? In order to do that, we're going to need a script. So I'm going to go to create, I'm going to go and make a mono behavior script, and I'm going to call this repeating background. Let me capitalize the B, background. Alrighty, open it up, Visual Studio. Whoop, it's yelling at me. Just real quick. Oop. Okay. So the very first thing that we're going to kind of like want to have and want to see is we're going to want to know what speed we're going to move our backgrounds at, right? And we can use a vector 2 here, but since we're only moving in the x direction, I think I'm going to just say private float background speed, right? And we don't really need start for right now because we're just going to get our backgrounds moving. Very first thing that we're going to need to do is get the background's current position, right? So I'm going to say vector3 position equals transform.position, right? Because we need to know where we're currently at. We're going to edit that and reapply it to the position in the transform, right? So we only want to update the x. So I'm going to say minus equals background speed times time dot delta time. Now, you might be asking, what, I could spell, what is this time dot delta time? In update, we only have, update happens as fast as your frame rate is. And if I were to play this on a worse computer, my frame rate would be lower. And we don't want our background to be moving based off of our frame rate. That means on a slower computer, it's going to move slower. On a faster computer, it's going to move faster. But we don't want that. What this time.delta time does is it takes the time between frames and normalizes any actions based off of that. So by multiplying this, it says, well, if you're running at 30 frames a second, that means you have 1/30th of a second between each frame. If you're running at 60 frames a second, you're getting 1/60th of a second every frame. So by multiplying by this, you end up getting to the same speed no matter what your frame rate is. So let's see what happens if we just do this. We're getting the position, we're subtracting it. Let's put that script on our two backgrounds. Repeating background. There we go. Let's do, I don't know, I want them to move fast. Let's do repeating background, or background speed, and nothing. Interesting. I did this here, and we haven't really talked about this in these videos, but what this is called it's called a local variable. It's something that, like, it's not the object's position, but it is a reference to it, or a copy of its value, right? We're not actually changing the position yet. We're simply saying, hey, I get the position. For our first background, it's 0, right? It's 0, 0. And I'm going to do some math and say, okay, this is a copy of its position. I'm changing its x. What I need to do then next is say transform.position equals position, or equals POS, right? Because that says, okay, I did my math to this temporary variable, and now I'm reapplying it to the actual object's position, right? Let's see what happens now. It just goes. Unity didn't used to actually, like, the code would have to recompile and rechange. You have to restart it. But it goes. It goes, and it keeps going. That's not ideal. That's not what we want. So, let's think about this. If my background is starting at 0, 0, 0, where do I want it to flip back over? Because essentially what's going to happen is it's going to go over here, and then it's going to scroll, and it's going to do the same thing, and the same thing, and the same thing, and the same thing, right? Well, I would want it to happen right when it gets to the edge here, and what do you know? If we look at our x over here, -8 kind of sounds familiar, right? Let me undo some stuff. That seems like a number that we've seen before. At least it makes a little bit of sense to me anyway. Because if I click on my background here, we have 100 pixels per unit. We have 800 pixels wide. It would make sense that if this is fully on the screen here, we would want it to go -8 to the left in order for us to say, okay, it has gone off screen. Hopefully that makes sense. So if I move this, I'm going to go ahead and put it right up to the edge. We're going to take this one and move it away for a second. I'm going to put this at 0, 0, 0. And I'm actually going to take my camera and make it a little bit smaller so I don't have these borders. Not that way. I'm going to go ahead and make it a little bit smaller here. Bam. Okay. So now then I can't see the blue background. And if this is at 0, 0, 0, that means it's halfway across is halfway from its center to the right edge is 4, that would mean that, actually no, you would just want your second background to be 8 to the side too. That way then the seams match up just perfectly, right? Now, we know that we need to go -8 to the left before we flip over. So let's mess with our code just a little bit more. All right, so we're going to say if position.x yeah, we can do that. If position.x is less than -8, print, we should flip. Looking at my notes here to make sure I get this right. This is one, just because it has a little bit of math to it, I always want to double check what I'm doing. Okay, so once this hits -8, it's going to print that it should have flipped over. There it goes, and there's a second one, and then it keeps going and going and going and going. So I want to do something a little bit different than what we usually do. I want to write a function to handle this. And I'm going to write a couple things that won't make a whole lot of sense, but I want you to follow along, and then we'll go through some of it, and some of it will come back later. Okay, so, right. What this is pretend, I want us to ignore this protected and virtual real quick. That will come back in later. This part I want to dive into though. Otherwise, this is just a normal function, right? We're going to handle when the background goes off screen and go over. This ref though, whenever we pass a value in here, we talked about how this, and I'm actually going to make this position, because these are not the same thing, right? This is if we didn't have this ref and we called, let's do this, handle off screen ref position. Let's do this. So we are going to call the handle off screen, and we're going to say we're giving you the position. Now, if I were to just do this, we would just be giving a value to it, right? We would just be saying, okay, whatever math I did here, whatever the value currently is of position, that's what we are sending over here. And it's just the value. It's not an actual reference to this. So if I were to, for example, say position.x equals 0, this wouldn't become 0, this POS right here. This would just say, well, this variable in here is 0, and we're not doing anything with it, so that's kind of silly, right? But if we were to add the ref here, what it says is, okay, this position is the same thing as this. It's kind of like a nickname we're applying to it, right? And if I change it here, on the next line, when we set this position, this transform.position to POS, it will have updated with this line, which is what we want, right? We want it to update. Now, I think what we're going to want, let's save it and let's look. If we have this here, I think, and this is where math kind of, my brain gets a little screwy. We're actually not going to want this to be 0. We're going to want it to be 8. So let's go ahead and try it. See what happens when we do. We're going to want to go 8 to the right, right? Okay. Ooh, we got a little bit of a gap, but now that we've got stuff, still a little bit of a gap. Ooh, not liking that. Let's take a look at our second background. We have 0, we have 8. So I think I'm gonna, Let's take a look here. I'm gonna pause the video real quick because I'm doing some math wrong, and I wanna, I'll cut back in just a second to see. Figured out what the dealio was. So what we're going to do is, instead of setting it straight to 8, because sometimes this might apply at just like a small frame of like a little bit of a difference, right? We're going to add double the how much we've moved, right? And I said in the last video that we really didn't like magic numbers, and that's what this -8 and this 16 are, right? It's not ideal. So how far along should our background go, right? It should go 8 units to the left. So I'm going to make something called a constant. And I always get this wrong a little bit, so let's see. We're going to call it scroll width. And we're going to say it equals 8. And instead of having all of these numbers in our code, we're going to have, oh, I forgot the C. Scroll width. And we're going to say scroll width times 2. So what, ooh, I did it again. I do this constantly. Forgot to lowercase the s and capitalize the W. There we go. So what this means is we have a constant, and this it sounds like what it is, right? It's a variable that will never change. The reason you go about using constants, and you don't technically ever have to, but that means code outside of like here can't change it, and it saves some memory. It's just like something that will never change. It's kind of more performant. So with this being said, we should see our background work really, really well. There we go, no seams at all. The adding, instead of setting it directly equal to it, means that if there is a slight decimal change, that the gaps won't slowly grow and build apart, right? But this isn't really that much of an interesting game. In the next video, these videos for Tappy Plane are going to be a little bit shorter, hopefully. We're going to talk about getting our ground moving and talk about where that protected and that virtual comes into play. So awesome. Thank you so much.